Okay. Does anybody need a copy of the worksheet from yesterday? Kristen, Medea, Isaiah. Couple other announcements. Thursday there will be a quiz on section 6.1. Since we don't have class on Friday. I'm going to give everybody a break and just say tomorrow is 100% off. I'm not going to post a video for anything. Friday, however, though, I will probably post a video. I might not cover anything new than what we talked about at the end of Thursday. We'll see. So Thursday we will do the quiz at the beginning of class. We will start 6.2. The video that I post on, I'll probably post it on Thursday for on Friday. That'll be an extension of section 6.2. I might put some extra examples on there as well for everybody to look at. Monday when we come back, we'll probably wrap up section 6.2. Maybe I'll just make a worksheet, or we'll do some more additional practice, more examples. We'll start 6.3 on Tuesday. And it's not next weekend, I think, but the following Monday, I think, will be off for Memorial Day. So next week is a full week, but the week after that, we'll get another day off. We only have, I think, let's see, after 6.1, there's only like maybe 6 sections left. Martin, do you have a question? We have one more exam, and that'll actually cover chapter 6 and chapter 7. Okay, so there will be a few more sections than on this first exam. I generally the third exam is what I see the lowest average on. Okay, not trying to scare you, all right? When you got to dig deep and work harder at the end here, because this third test tends to be the hardest test. Okay, I'm probably doing a disservice. I'm probably scaring some of you more than I should. Okay, but if you do a bunch of practice and you crank it out and you dig deep and you work hard, it's not going to be necessarily that much worse than these first 2 exams. Okay, and then like I said, I put a lot of stock in the final. Generally, students who pass the final, I pass you for the most part, unless you've really done a terrible job doing your homework. Okay, if you've made an effort and you pass that final, generally I will pass you. Okay, so you know, you can go ahead and you can feel bad about a low score on a test, but I think ultimately the best thing to do is just be buck up and put a big effort into the end here, and if you pass that final, I will pass you, unless you've really done a poor job and you haven't really been doing any work. Okay? So, again, I put a lot of stock in that final. Okay. So, again, anybody need a copy of the worksheet from yesterday? Gerardo? Claire show up?
Claire has
got a lab.
chemistry today, yeah. So I don't know if she will. You need Jake too.
Jake show up? Oh, Jake's in the lab as well.
They're in the same chem class.
Okay. Well, let me make sure I'm recording the video then, and then that way they can watch it. Okay. So what we did yesterday was, the main thing was using what are called fundamental identities to either verify identities, and what we're going to do today is we're going to solve equations. So I got through all the examples except for the very last problem on the last page. Okay. And then once we finish this, I've got somewhere in here, I've got all the problems from the textbook. I'm just going to start writing problems on the board and we'll do some extra practice. Okay, so example 7, it's really example 8. I screwed up on the numbering. Okay, so this is the last problem here. It says, find all solutions to the equation 2 sine squared theta minus cosine squared theta equals sine squared theta. And actually, I don't know why I put on the interval from 0 to 2 pi. Cross that out. We're going to find literally every single solution, period. Okay? On your homework, you will be having to, I think, find all solutions to these equations. So you're not just going to be finding solutions in an interval anymore. Now you're going to find all solutions. So what happens is you get a family of solutions involving an integer k. Okay? So we're not looking on an interval anymore. So cross that out. It should just say find all solutions, period. We're not going to look on a specific interval. Okay. So think about a couple ideas for a moment. So think about maybe one thing you could do to try and solve this. You've got to think of some sort of identity from your previous page that has all the fundamental identities. And actually it looks like maybe I was wrong. So maybe it's in the next section where you find all solutions. So I guess I'm kind of confusing myself, so maybe we do. My bad. We do want to look on 0 to 2 pi. But in the next section or the next, so either 6.2, 6.3, or 6.4, we're going to start finding all solutions to equations like this. Okay, so I'll stick with what the problems in the textbook are doing. They are asking for solutions on a specific interval. So good thing I printed that off today. Okay, but like I said, in the future we'll find all solutions. Okay, so what are all our identities? Okay, so we've got to think of maybe using some identities to maybe write this equation in terms of just sine or just cosine. Right now the problem is you've got a sine squared term, you've got a cosine squared term, and you have another sine squared. Okay, so ultimately one of your goals when you're solving these equations should just be to write the equation in terms of just one single trig function. And then you could solve for, say, sine theta or cosine theta. Okay, is there any identity anybody sees that involves a sine squared or cosine squared?
Sine squared plus cosine squared equals 1.
Okay, so the Kirsten said the sine squared plus cosine squared equals 1. Okay, so remember the Pythagorean identities. Sine squared theta plus cosine squared theta equals 1. Now, which one would be more work? Would it be more work to write everything in terms of sine, or would it be more work to write everything in terms of cosine? Yeah, I think it'd be more work to write everything in terms of cosine because you'd have to replace both the sine squareds. So I think it's a lot easier to just replace the cosine squared theta. Okay, so coming back to your identity, if you solve for this cosine squared theta, you can subtract sine squared to the right and get cosine squared as 1 minus sine squared. And then what we'll do is we'll plug that in right here. Okay. So what happens is you get 2 sine squared theta minus 1 minus sine squared theta. And then you still have the sine squared theta on the right. Okay. So step 1 is replace that cosine squared with 1 minus sine squared. Okay. And then now what you can do, anybody have an idea? So now what do I have to do with this negative sign? Okay, we'll have to distribute the negative through both these terms. So I'll get 2 sine squared theta minus 1, and then minus a negative sine squared gives you a plus sine squared. Okay. And then any ideas from here?
Combine like terms.
We can combine like terms. Yeah, or, so there's several things you could do here. Martin, you said you could subtract a sine squared, right?
Mhm.
That's just going to make a 0 on the right-hand side. Or you could do what Kirsten said too, and you could combine the 2 sine squared with the single sine squared. Either way, it doesn't really matter. So I think what I'll do is I'll first subtract the sine squareds on both sides. And the result would be 2 sine squared theta minus 1 equals 0. Okay. And then where can I go from here?
Add the 1, divide the 2.
Okay, so we can isolate this sine squared, right? So a lot of you said add 1 to the right, divide by 2. So sine squared theta would give us a positive 1/2. Okay. And then what's our next move?
Square root.
Okay, so I heard a square root both sides. So sine theta is going to equal, is it just going to be the square root of 1/2? Okay, right? If you can square a positive or a negative to get a positive 1/2. Okay, so you should have a plus or minus the square root of 1/2.
Would you do arc cosine? I mean arc sine.
We are going to use arc sine in just a moment, but we have to split this off now. We're going to really have 2 equations. So this ultimately splits off into 2 equations, either sine theta, and if you do square root of 1 over square root of 2, you'll get a 1 over root 2, or sine theta has to equal minus 1 over square root of 2. Okay, so I set sine theta equal to the positive square root, and you set sine theta equal to the negative square root. We can think about unit circle stuff if you like. Okay, so we're just looking for solutions on the interval from 0 to 2 pi. Like I said, later on we'll find all the solutions, but for now we're still working in an interval. Now, which quadrant does the angle have to be in to give you a positive sine value?
Top.
1 or 2.
Either 1 or 2.
It'll be 2.
And what's the first one up here? That'll be 45 or pi over 4. How do I know I want to use radians?
Because it's in 1, 2, 5.
Yep, because we're looking at the full rotation from 0 to 2 pi, so we're using radians. Okay, so one angle, and I guess we don't really need arc sine here because 1 over root 2 is a special value. And I know that pi over 4 will work. And then, won't there be an angle in the second quadrant that also works with the same reference angle?
3 pi over 4.
So if that's pi over 4, right, pi minus pi over 4, or 3 pi over 4 would also be a solution. Okay, so you can do pi minus the first angle if you like, or you can use the fact that the angle in the second quadrant would have to have a reference angle of pi over 4. So this angle would also be pi over 4, meaning the angle itself getting to the terminal side would be 3 pi over 4. Okay, and then the second equation, sine theta equals minus 1 over root 2. Those angles have to be in the third or fourth quadrant. They both also have reference angles of pi fourths. So what are the other 2 angles?
5 pi over 4 and 7 pi over 4.
Yep, so starting at pi, you would add pi over 4 to get 5 pi over 4. And then what's the other one you said, Wyatt?
7 pi over 4.
Because you can start at 2 pi and subtract pi over 4 to get 7 pi over 4. And there are all your solutions in the interval from 0 to 2 pi. Now, if you wanted all solutions, all you'd really have to do is just add 2 pi k to each of those. Because sine is 2 pi periodic. So you can add any multiple of 2 pi to all of these angles. I'm only saying that now because we're going to use those ideas later. Okay. but we'll get there. Okay, so there's 4 angles between 0 and 2 pi that satisfy this equation. Okay, and then also think back now, right? We have that contrast between what an identity is and what a equation is, right? An equation is something that's only true for some values as opposed to an identity that's true for all values, right? Like, for instance, the Pythagorean identity works for any angle theta you plug in, whereas this is an equation because it's only true for certain values. Alright, so let me just pick some problems to solve, give everyone a chance to practice one. You're going to have to use fundamental identities. So I'll give everybody a few minutes to think about it and work on it. So let me give you another equation first, and then we'll do a couple verifying identities problems as well. And again, sorry, I didn't have time to get a handout made. I rather, wanted to get all the tests graded, and I didn't have time to get a worksheet put out. So you might look out, some of these might already be homework problems. I didn't look at what the homework problems were before I came in here. So say number 48, this is 6.1. What if I tell you to solve 4 cosine theta sine of theta minus pi over 2 equals -3, and we're going to solve that on the interval from 0 to 2 pi. So keep your handout out. You might want to go to the page that has all the identities on it. I believe that was page 2. Yeah.
In terms of like the test and quiz, are we going to be given these?
You'll be given some of these identities, so you'll have to memorize some, but not all. And sometime before the test, I will send you a copy of all the identities, and some of them will have blank boxes. Those are the ones you'll have to memorize. So for the quiz, I might just be nice and let you use them all for that. Okay, and then, because I don't have the whole sheet made ready for the exam. So on the quiz, I might just print this page off and let everybody use this fundamental identities page, okay, on Thursday. But for the test, you'll have to memorize some of them, okay, but not all of them. And you might actually have to fix something first before you even use one of the identities. And this is actually one of the homework problems.
Yeah.
The next one I'll put up there won't be that. Okay. So anybody have some initial ideas? So it looks like the identity that we're really going to have to use is the identity on the page as well. Is it actually sine of pi over 2 minus theta equals cosine theta, correct?
Mm-hmm.
Yeah.
Okay. But when you look inside these parentheses, it's kind of, you've had this multiplied by a negative, right? So when you look over here at the sine theta minus pi over 2, this is what I meant where you had to factor a negative out of the inside. That's how it becomes a minus pi over 2 minus theta.
That's just negative cosine theta then?
Or is it cosine negative theta?
So we don't have an identity that says sine of minus of the pi over 2
Yes,
minus
it's
theta.
cosine negative.
But we have another identity that says sine of minus an angle. So is there something that tells you what to do when you have a minus in front of the angle? You can bring it out front. So you actually have to use two identities. And by the way, all I did was I factored a negative out and then I switched the order of the terms. If you factor a minus out of pi over 2, you get positive pi over 2. If you factor a minus out of theta, you're left with a minus theta. Okay. That's a simple algebra thing. Okay, and then I pulled this minus out front, and then now sine of pi over 2 minus theta is cosine theta, so that just becomes minus cos theta. Okay, so if somebody did say minus cos theta, you were correct. I think, was that you, Brady? Sorry, I just want to make sure I'm giving credit where credit's due. Okay, so like I said, the inside of this expression is multiplied by a negative. So before I can apply this property, I had to factor a negative out of this expression and then use the even-odd identity to pull this negative in front of the sign. And then what's left over now is minus cosine theta. So this is now, the equation becomes for cos theta, and then the sine theta minus pi over 2 becomes a minus cos theta, and then you still have a minus 3. And then what does the product on the left give us? When you multiply the 4 cos theta and the minus cos theta.
Negative 4 cosine
Square
squared.
theta.
Yep. So you should get a minus 4 cosine squared theta equals minus 3. Yep. Okay. And then now I can do what on both sides?
Divided by 4.
Okay, so divide by the minus 4. We get cosine squared theta equals 3/4. The negatives will cancel each other. Okay, and then square root both sides. So I'll get a plus or minus the square root of 3/4, which is really plus or minus the square root of 3 over 2. And Claire, it's really out of 50 points. There's 52 available, but it's out of 50. Like I said, it's really out of 50 points. There's 52 possible. So it's possible to get over 100 of them. Okay, so now what am I going to do? Kind of like before, if you have cosine theta's plus or minus a value, that'll split up now into two equations. So you're going to get cosine theta equals the positive root 3 over 2. And you'll also get cosine theta equals the minus root 3 over 2. We're only looking at solutions in what interval again? 0 to 2 pi. What we can do is we'll draw a unit, so I can just draw a unit circle to help us. Now, which quadrants is cosine going to have a positive value? And sorry, let me actually label these quadrant 1, quadrant 2, quadrant 3, and then quadrant 4.
1 and 4.
Okay, so 1 and 4, that's where cosine's positive. And what about the angle in the first quadrant? What's the angle in the first quadrant that gives us root 3 over 2?
Pi over 6.
That'll be pi over 6. And then that means this other angle now, to get down here, also that's going to have a reference angle of pi over 6.
So 11 pi over 6.
Okay, so you'll get a pi over 6 and an 11 pi over 6. And then for the other one, cosine is negative in the second or third quadrant. All the reference angles for these angles are going to be pi over 6. So here's the other two angles, and these little angles here are pi over 6. So this angle right here is going to be pi minus pi over 6. So what should that angle be?
5 pi over 6.
That'll be a 5 pi over 6, and then finally the next angle would be pi plus pi over 6, which would be 7 pi over 6. And there's your 4 solutions to the original equation. And then let's practice maybe one more before we go on and do a couple identities. So this one is going to be somewhat similar to a homework problem. So number 51 says to solve 4 tangent squared x plus 8 tangent of x equals 5 minus secant squared of x, and we're going to do this on the interval from minus pi over 2 to pi over 2. Okay, first, we can't solve this as written because we have a combination of tangents and secant squared. Okay, now in particular I want you to focus on the tangent squared and the secant squared. Does anybody see an identity on the sheet that involves a tangent squared or a secant squared?
Yeah.
Okay, so we've got the other, again, it's another Pythagorean identity. And if you don't remember this one, I always start with sine squared plus cosine squared x equals 1. And if you divide everything by cosine squared, what did you say it was? It's tangent squared x plus 1 equals secant squared x. So if you just divide every term by cosine squared, you get this identity. Okay. And then that'll allow me to replace the secant squared on the right with a tangent squared plus 1. So now you have a 4 tangent squared x plus 8 tangent x equals 5 minus, and then the secant squared becomes a tangent squared x plus 1. So one general rule of thumb with these types of equations, you always try and write them in terms of a single trig function. So if you have a mixture of two trig functions, you have to use some identity to write one of them in terms of the other. Okay, now let's see. This part might be a little maybe tricky at first until you recognize something. Okay, if you treat tangent x itself like a variable, this almost looks like a quadratic. In fact, this is a quadratic in terms of tangent of x. So what do we do when we try to solve for quadratics? We always try and get a what on what side? Always try and get a 0 on what side? Or one side. So I guess before we do that, we have to distribute this negative sign and then move all terms to the left. So you'll get 4 tangent squared x plus 8 tangent of x. And that's going to be 5 minus tangent squared x minus 1. This next step I'm going to do kind of quickly. If I add tangent squared to the left, I'm going to get a 5 tangent squared. So I'm adding the tangent squared on the right to the left to get 5 tangent squared. There's only one tangent term. And then what would be the last term? Well, 5 minus 1 is 4, and then we subtract the 4 to the left. Okay. Like I said, this is basically a quadratic equation where we're treating tangent as the variable. Okay. So what you can do now is you can solve for tangent of x using what formula did we typically use to solve quadratics if we didn't see how to factor them right away?
The quadratic.
Yep, we can always use the quadratic formula. Maybe this factors, but I don't know. I could try and factor it and see. Let's try that first. If it doesn't factor, so to get a 5 tangent squared, one factor would have to start with 5 tangent and the other would have to start with tangent. And then there's several ways to make that 4. I don't know if there's any way to really get an 8 out of it. I think a 1 and a 4 might, no.
No, because then it'd be that.
2 and 2 would maybe do it. But then I'm going to have 2 tangents plus 10.
No, you would be.
I think this'll work, right?
10 minus 2 is 8, yeah.
So which one has to be the plus here? I think this has to be the plus and that has to be the minus. Because you've got to get a positive 10 tangent minus 2 tangent to get the 8 tangent. Okay, so because we saw how to factor this, I can skip using the quadratic formula, but you can always use the quadratic formula if you don't see how to factor it. Okay, so that gives us now 2 equations. Most people have maybe seen the zero product property used, but if you have a product of 2 factors equaling 0, that means you can set each factor equal to 0. So I can do 5 tangent x minus 2 equals 0. And then the other one we have to solve is tangent of x plus 2 equals 0. Running out of good markers. So you solve this one for tangent, you get tangent of x equals 2/5. Over here you get tangent of x equals -2. Now are those special values? Right? For tangent, you'd have to either see +1, 1 over square root of 3, or something involving square root of 3. Okay, so these are not going to be a result of special angles. So now's the time where you can use arctangent. Okay, so when we solve for x in the first one solution is going to be tangent inverse of 2/5. And make sure your calculator's in radian mode because our interval is given in radians. Mine is still in degree mode, so I have to switch. I'm still in terms of the last test. And and I get approximately 0.38. Okay. And then notice, let's see, we have to make sure we're in the interval from minus pi over 2 to pi over 2. I'm just going to get an approximate on these so we know if we, because we can, tangent is pi periodic, so I can start trying to add or subtract pi's from this to get other solutions. So what's pi over 2 give us?
Negative
Approximately.
Negative 1.57.
So it's about 1.57 and 1.57. So if you add and add and subtract pi to that, I'm too big if I add pi, and we're too small if I subtract pi. Okay, so that's the only solution to this equation in the interval from minus pi over 2 to pi over 2. And then same thing over here, we can solve for x by doing, I'll just write it in the other notation just for us to see. So I can do arctan of negative 2. Again, make sure your calculator is in radian mode. Mine keeps wanting to leave to go back to degree mode. Now this time I get minus 1.1, well, we'll do it in 2 decimal places. I get minus 1.11. Is that between minus pi over 2 and pi over 2?
Yeah.
Oh yeah, that's one.
Yep, that's between the minus approximately 1.57 and positive 1.57. And if you add pi to that, you're going to be outside of the interval. So there is your second solution to the original equation. Okay, so sometimes you have to use quadratic formula or factor. When you replace everything with identities, you might get an equation that's really quadratic in terms of the trig function. You can either try and factoring it. So you're just treating tangent of x like it was the variable x to begin with. Okay. And then, like I said, if factoring isn't easily seen, you can always use the quadratic formula. So, all right, and then we have a few minutes left. Let's maybe do some identities, at least one of them. Let me see what the homework problems are. Let me do a different one. 38, 39. Okay, so I'm going to take 37. So this is 37 in the text. We're going to verify the identity. Sine of x cosine of x minus sine of minus x over secant x. And this is supposed to equal 2 sine of x cosine of x. Okay, now what's the ultimate golden rule of these identities? You can never assume that this identity is true to begin with. It's kind of like a mini proof. We're trying to show that this is true. Okay, and it's not an equation. Don't try and solve it. Okay, if you try and solve this thing, you're going to get down to something like 1 equals 1 or something that's always true, 0 equals 0. Okay, so you can't just try and solve these for x, because this is supposed to be true no matter what x I plug into it. Now, the other thing I like to do is I start with one side or the other, and I generally like to start with the side that looks more complicated. Okay, well, 2 sine of x cosine of x looks pretty simple to me. So what we'll start with is we'll start with the left-hand side and simplify into the right-hand side. And we do that by just we simplify algebraically and we apply identities. Sometimes we have to add in extra terms, like multiply by something that's equivalent to 1, add something that's equivalent to 0. So I'll start with this left-hand side. And if you look ahead a little bit, we already have a single sine of x cosine of x. The minus sign minus x over secant x is supposed to end up being another sine of x cosine of x, so we can get 2 of them. Okay, so we're not really going to mess with the sine of x cosine of x. What we're going to simplify is this minus sine negative x over secant. Okay, and I don't think this one's actually too tricky, so anybody have any ideas here?
I might want to distribute that negative first.
Okay, I guess I could distribute the negative, or another way I could get rid of this negative is by doing what with this one?
Even out identity.
Yeah, so what you're saying is equivalent,
Yeah.
right? You could turn this into a plus, put the negative here, and bring it inside. But instead, what I'll do is I'll bring the minus out front. So this will be minus a negative sine of x over secant of x. So I used the even-odd identity, as some of you said, for that first equality. Okay, and then what happens when I do a negative times a negative?
Positive.
That'll become positive, so you get sine of x cosine of x plus sine over secant. And then again, looking ahead, we're supposed to get 2 sine of x cosine of x. So sine of x over secant is supposed to be sine cosine. So anybody see how to do that?
You're going to turn secant x into 1 over sine.
Okay, so we're going to turn the secant into, so we're going to use the reciprocal identity. So this will be, I guess we could write it this way too, right? I can write this as sine of x times 1 over secant. So I'm kind of splitting that fraction. And then 1 over secant is really cosine. So I get plus sine of x cosine of x, which gives us the 2 sine of x cosine of x. And we're done. Right. Notice there's no answer to these questions, right? It's just verify this identity is true. Okay, so I started with one side and we used algebra and identities to simplify to the expression on the right. Okay. And then I probably have time for one more. I can at least get one started, but I don't know if we have time to finish it. We can probably finish it if I just run through it quickly, but... So this is number 36. We're going to verify the identity 1 plus sine of x equals cosine of x over secant x minus tangent of x. Okay, and again, where this is useful in calculus, you might set up some equation, you're doing an application problem, and when you set it up, you get something in this form. Okay, but this form isn't necessarily very simple. 1 plus sine of x, though, is pretty simple and easy to work with. Okay, so again, you start with what looks like the more complicated side. So we're going to start with the right-hand side this time and simplify into the left-hand side. So we'll start with cosine of x over secant of x minus tangent of x. And we kind of used the trick, yesterday because there's no way to split this fraction up because the addition or subtraction is in the denominator. Does anyone remember the trick I used yesterday? I multiplied something by... there we go. Claire got it. So, but I'm pretty sure that's what you meant, right? So, yeah, you multiply top and bottom by the conjugate of the denominator, which is secant of x plus tangent of x on top and bottom. Okay? And then what I'll do is I'm going to leave the numerator I guess like this for now. If we need to distribute the cosine through, we will. And when you multiply something by the conjugate, you only have to multiply the first and the last terms, if you think FOIL. So you're going to get a secant squared of x minus tangent squared of x in the denominator. But something really nice happens with that denominator. Once everyone catches up, got a couple people writing here.
I thought you could run.
Yeah. So if you look at our Pythagorean identity, if I subtract the tangent over to the right, 1 is the same as secant squared x minus tangent squared x. Okay. So the denominator just becomes positive 1. So this is cosine times secant x plus tangent x. Now, can anybody maybe see we're trying to get to 1 plus sine of x? What's going to happen when you do cosine times its reciprocal secant? You get positive 1 plus what happens when you multiply cosine times tangent?
You get sine.
I guess let's actually write these out a little bit, because you've got cosine x times secant x plus cosine times tangent. I want to make sure I show you every step. I don't really want to skip anything at this point. Okay, so this is cosine of x times 1 over cosine of x. So rewrite secant in terms of cosine. And then it's plus cosine of x. Tangent is really
Sine over cosine x.
sine of x over cosine of x. And then what happens to the cosines? And you're left with 1 plus sine of x. That verifies the identity, and we're done. So this is where I was saying the next test, it's easy or hard. It depends on how much you put into it, because especially with this identity verifying, you don't really see what you're supposed to do unless you practice these enough and you build a good intuition for what to try. Right? When I see something like this, I'm kind of like, okay, I got to get rid of the fractions somehow because the left side doesn't have any fractions. Well, I can't split up the fraction because the addition or subtraction's in the bottom, so that's a case where you can use the conjugate trick. Okay, so really it just takes a lot of repetition and practice. And then you build some intuition, right? You'll kind of look at something and be like, oh, I've seen something like this before, let me try this. Okay. So, all right, I'll see everybody Thursday. I can't make my office hours tomorrow. So maybe what I'll do is I'll double up on Thursday or something like that, but I'll let everybody know. So enjoy your advising day, everybody. Oh, okay. Okay, so Thursday, you're going to miss Monday. One thing you could do is, if you can come into campus, you could certainly take the quiz on Friday.
I won't be here Friday.
Okay,
we're
so you're
going
gonna
this
be-
weekend. It's that whole weekend.
And it's for, is it for softball?
Yeah, it's our last one. We earned it and
Well, you can either do the quiz tomorrow, or let's do it when you're back
okay.
on Tuesday.
Perfect.
That works for me.
Thank you.
I don't really see any other way. Unless Justin wants to give it to you, but I doubt he does.
Okay.